So very good afternoon to all. So in smart sensor and application, unit number 3 is communication for smart sensor. So now how we are going to communicate? Okay, that is with respect to this unit number 3. And for today's class, we will see overview on communication. And in the overview of communication, we will see some definitions, and there are some background for communication. So previously, what was done? What was the previous way of communication? Then organization and standards. See, when you make a product or when you define any particular rule for communication, then there should be some standards. And we will see an example is automotive protocols. So protocols which is used in automobiles. One among is CAN. So that is what we are going to see today. Okay, so some definitions. What is meant by protocol? A protocol is an agreed on set of rules for communication. See, when you say you are going to communicate, there must be some rules. When to do, how to do, when to start, what is the procedure to start, how to check, what is proximity, what is priority, what is inversion, then all such things. So all that things are called as set of rules. The bus can internal or external circuit components and can be serial or parallel. Serial approach is more common. All this is called protocol. Device line bus. Device line bus connect basic control elements, the sensor, activator to the host controller. So device level buses, you might have learned something called internal bus. That internal bus you call it as 8-bit architecture, 16-bit architecture, where your data lines you call it as 8-bit, 16-bit. You even have address lines like 8-bit address lines, 16-bit address lines. But now we are saying device level bus is nothing but between the sensor and the system. Okay, so that is called device level bus. Then comes multiplexing. Multiplex, we all know MUX. It is multiplexing of combining several of messages from transmission over the same signal path. For example, Google. We all know Google is a server. That same Google server is being used by n number of person at a particular point of time. So there we will do multiplexing. The data will be multiplexed from the Google server and will be sent, and then it will be separated and it will be given to 2 or 3 person depending upon the requirement. Then comes collision detection. What is meant by collision? See, we say college is till 3:30, but sharp by 3:30 if I ask you to leave. So when you start, if all the person try to come out of the class at the same instant, then there leads to collision. Similar way here, access of bus is obtained through an arbitrary process. The bit by bit arbitration is called collision detection. So how many data is being sent, how many data is being received. So if some data is not received, that is lost due to collision. Okay. Then latency. Say I have left the class by 3:30. Then I am waiting in reception and seeing how many person are coming. If some are not coming, then I will declare latency that he should have come within this time. So something has happened. See, for best example, when you go to Tirupati, at the bottom of the climbing the hill, they will punch and give a paper stating that this is the time you have started your journey from the bottom. Why they do this is they want the record whether all are coming up or is there any issue in between. So that is called as latency. Okay. Then comes that data link controller. It is a silicon implemented protocol that handles all communication requirements. Communication requirements is like when you say router, when you say hub. So what is the difference? You should know what is router, what is hub. Hub is just place where everything is added and given together. But router, you will have some knowledge that if this data is coming, this has to be sent to this particular device, then what is the best route, what is the minimum route, all this devices comes under data link controller. So background, the International Organization of Standards ISO has defined the open source interconnection, we call it as OSI model, that describes 7 layers for data networking. When there are two systems, when you want to send the data between the two systems, to transfer the data between the two systems, a person called ISO has defined a protocol called YSI. So how it has been done? Because the end user, we doesn't understand digital data and all, we doesn't understand ones and zeros. That is very difficult. So something you have to see on the screen is should be in English or the language which you know. That is Tamil, English, or language like human language, not machine language. So that is called as application layer. So from the application layer, it goes to data compression or user data conversion. See, from the monitor, whatever, if you keyboard, if you type, whatever you type, whatever on display, both should be combined, and it goes for data compression, because it cannot be sent through the line without any compression, so it will occupy more volume. For this you use a presentation layer that is going to present, and even you can say like Word, PDF. What is the difference between a Word and PDF? How you when a same Word file converted into PDF, how the size reduces, all that is called as data compression, that is done in presentation layer. Then comes session layer. Session layer will tell about the synchronization of dialogues, authentication, network management, all such things. Then comes transport. Transport layer will tell about the end-to-end communication, whether it is what type of communication you are going to go for transport. Then network, we all know routers, logical address. So network will tell about the address, the path, the channel through which all this is going to do. Data links are the components used like modem, all such things. Then comes your final person, which is called physical layer, which is the physical components which is used for transfer, like RS-232 cable, RS-232 jack, then like 8-bit jack or whatever. So physical layer is nothing but the physical quantities. So among this, you should know a word called CRC, that is nothing but cycle redundancy check. Okay, all this will be there in data link layer. Okay, in data link only you say about all routers and all. So whether whatever I send, whether it is reached or it not reached. So if it not reached, there is some issue. You might have seen in your home when you open a page, when you open a web page, in this web page you may see some images, and somewhere you might have seen even some cross, and that image is not visible. What is that cross indicates? That is data lost while the transfer. So from the website, it might taken some path to reach your system, and during that path that data is lost. So that cross mark you are able to see in that image, like small red cross mark. Okay, once if you refresh, it may even get the data and show you. So that is called, if it is not getting, it will send as CRC, cycle redundancy check failed. So automatically even it will refresh and try to get back the data. Then different types of networks. Star connected, which means center will be master, all the slaves will be connected to the master. So slave can communicate to master, master can communicate to slave, but one slave cannot connect directly to the another slave. Slave can communicate only through master. You have to tell to the master, that master may communicate with another slave, but no two slaves can connect, or data transfer is not possible. That is in case of star. In case of ring, there is no master at all. Data will be passed to all the person, whoever wants will take it, otherwise he will transmit. So this has some, even there is no master, but there is some issue. If any one device fails in the ring, that's all. Then the device after that particular fellow will not receive. Next come linear. In linear, 2 wire is kept common. Anyone wants to send the data can send through the wire. Now here no master, no slave. When you send the data, you will be master. When you receive, you will become like a slave. So first one you have seen, it is a master slave, but only master can communicate. Slave directly cannot communicate to other slave. Slave has to communicate only to master. It had one difficulty is, if you slave to slave communication, that is not possible. When you come to ring, there is no such master, everybody is connected. So that master problem is overcome, but if anyone fails, that's all, ring is open. So communication will not be to all. So taking into this two, I'm trying to bring a person called a linear, where I have everybody connected. Whoever want to be master, he can be master and he can communicate with anyone, and vice versa is possible. Okay. So regarding standard, there is something called RS-232, RS-432 and RS-422. All these are called point to point, and only RS-485 is called multi-drop. Instead of I say RS, here it is written as EIA. So just I have shown this graph is just to tell you this 3 comes under point to point standard, and this alone comes multi-drop standard. What is that point to point is, these 3 methods can communicate to any one. That means the number of drivers is only one, whereas in this 485 I have 32 drivers. Okay, so I can directly connect with the 32 fellow. Maximum cable length is, this is only 50 meters, 50 feet. This is 4000, 4000, 4000. This is only 20 kilobytes per second. This is 100. This is even 10 megakilohertz. Then operating voltage range, again this is 25, 6. This is between 12 to 7 volts. Okay. So moving into source or organization and standards. So all this was initially done in various universities. So each and every university were developing their own protocols. The institutions are like Texas, Harvard, and there are so many universities who have developed these protocols. So several universities has developed standards for communication. For example, University of Michigan has proposed a particular standard with the IMPS. Researchers at Default University of Technology has developed a serial protocol communication also. So like this, each and every universities, they were developing their own protocols for communication. So in this, for your syllabus, you can have CAN, controller area network, that we have in our syllabus. This was developed by Robert Bosch. So Robert Bosch, we all know that it is an industry who has developed this CAN, and with that CAN we are using now for automobile industries. So let us start with automobile protocol. So when you see automobile, so in automobile, let us take a latest car like Audi car or a Mercedes Benz or a Rolls Royce car. Okay, so in that car, you may know around 1000 to more than 1000 sensors are being placed for each and every task, and for this each sensor it is auto correct or auto zero, which means we have already seen in unit number 2 that each sensor will have its own microcontroller, and that sensor data will be used by that microcontroller itself, and you will take care of the action. For example, in latest car, you have come across window, your glass window on all the 4 doors. When you press the button and try to lift that window up, and suddenly if a person keeps its hand, what will happen? The glass will stop and glass automatically goes down. It will not make that hand to get compressed with the help of this glass and door. Okay, all that will not happen. That part alone is taken care by a sensor, and he has its own controller, and with the help of that controller he is able to identify, and he will try to stop the movement of glass, and he will try to protect. Okay, so now this controller will also communicate with the other controller if is required. For example, in latest car, when rain starts, automatically your wiper will start. Nowadays it is not required for you to put the wiper and all in car. Okay, for even in Ford Endeavour that feature is available. So if rain starts, if just a water droplet fall on my car, automatically my car will identify that it is raining, then automatically my car wiper will start. Okay, so you can see there is a sensor to see the waterfall, and based upon the intensity of rain, the speed of the wiper will also change. If the rain is slow, then wiper will move at very slow rate. If heavy rain, automatically wiper will move at a faster speed. No need for any manual operation from the driver. Okay, and if rain is there, one more thing is understood is all the glass should go up, otherwise water will come inside the car. So automatically for this also the same sensor, the sensor which identified the water, which will give the indication to the wiper system, as well as it will give indication to the glass, your window glass. So automatically, even though if you might have not done, at the back seat you might have your children's, they might have brought the glass down, but if the rain starts, automatically, see, you might have driving, unfortunately if you have missed, water will enter through that window. Your child will not see that your car gets wet, all that they will not see. But what happens in some latest car and all, automatically all glasses will go up. So now you can see a same sensor is sensing, but it is giving information to 2 or 3%. So now there is an interconnection between the sensors and the controllers. So that where you go for communication protocols. So there are so many types of communication protocols that is used in automobile. The major protocol is CAN protocol. Okay, CAN protocol is the one among the protocol. So that protocol will try to communicate and try to solve this issue. So controller area network. So this was the protocol developed by Bosch. Okay. So introduction. CAN bus is a vehicle bus standard designed to allow microcontrollers and devices to communicate with each other in vehicle. It is a message-based protocol of duplex. It is a multi-master serial bus. So at a time anyone can be master, he will send the data. It was introduced by Robert Bosch in 1986, developed for automotive application. It was made as a standard only in 1993. So initially this Bosch fellow, they used this CAN protocol, but only in 1993 it has made as a standard, which means thereafter anyone can use this protocol, which was developed by Bosch. So he has developed a standard, and the standard was given as a number ISO 11898/1. Rather telling as CAN, you can even call it as ISO 110891. So CAN has two standards. One is called CAN 20A, another one is called CAN 20B. One is 11-bit identifier, another one is 29-bit identifier. In the latest car which use so many sensors, they will go for 29-bit identifier. Okay, so this is how this CAN is going to work. So CAN is also a linear type. We have seen now star, ring and linear. So CAN is also linear. So you see there is a person called air conditioner inside the car. If there is a rain, automatically outside temperature will fall. This outside temperature will fall. So suddenly you will feel more chillness inside the car. Again, this is not advised. See, I have kept it 28 degree. Why should it go below 28 even though outside it is raining? So automatically this air conditioner will get the information from the same sensor, the sensor which I have told you now, the sensor you are used to see whether rain is there. Only water sensor, that's all. That water sensor, see where and all it is giving information. See, if rain falls on the car, it even sends the information to this air condition. Then seat belt, seat position, transmission is your gear arrangement. See here they are showing a car where the engine is at the back. There are some car where engine is in front. There are some car where engine in back. So in most of the German based car are left hand drive, and the dicky is on the front side and the engine is on back side. They say when they go for any collision, when your car goes and it, what they claim, if the engine is not in the front, then even accident to the greater extent can be reduced because engine at the back. But you should not claim that someone come and eats. That is the case different. That has been done by some other fellow, not by my driver. If my driver goes and eat, the engine should not get affected. That's what they say. Then suspension, now and all, we doesn't go for oil suspension and all. It has come to air suspension, and there is so many improvement. Similarly in brakes, we have something called the ABS, anti-locking brake system. So in olden days when you press brake, suddenly brake will apply and you will try to bring the movement of wheel to zero. but the car will not stop, rather car will slide. Car starts to slide because all the four wheels are rest, but you have come at 60 or 180 kilometer speed. Now rather stopping, it starts sliding. So in ABC, what they say, apply the brake at the pulsating method. Apply relieve. You do this at a repeated speed, so that speed is brought to zero. Your car will not slide. So all such things. Now you have a controller for battery, controller for engine, controller for transmission, controller for seat. So each and every person is having a separate controller, and he is going to do the control operation. So we will stop with this today. So just I have given some basics of